Alright, so today we're going to be talking about solving rational equations by a common denominator. So we talked about the first type of rational equation, and that was cross multiplication. Now we have our second one, which is common denominator. So that means we're going to have more than one fraction on one side of our expression, and so there is no common denominator, and so we have to find one. So, as you can see, that's what we're going to be doing today. So a couple things that we need to remember is that a rational expression is not defined when its denominator is 0. Remember, we call these excluded values. Kind of like extraneous, it just doesn't work. Alright, so the steps for these is just finding a least common denominator, eliminating all fractions by multiplying both sides by the least common denominator, simplifying, solving, and checking those excluded values. Alright, so let's get started. Let's get into this first example. Alright, so first things first, we have x minus 5 over 2 plus 3 equals x plus 3 over 4x. So first thing I notice is that this 3 isn't in a fraction. Well, remember what I said last video is that we're technically all in fractions, it's just that we have a implied 1 under us. Okay, so that 3 has a denominator of 1. So we have 2, 1, and 4x as our denominators, and we need to find the least common denominator. So what is something that they all have in common? Well, that is 4x. Alright, because we can get 2 to 4x, we can get 1 to 4x, and we can get 4x to 4x, meaning we can multiply each of those items by something to get 4x. Alright, so now let's multiply that least common denominator. So what I'm going to do is I'm going to do 4x times x minus 5 over 2. And then I'm going to do 4x times 3 over 1. And then I'm going to do 4x times x plus 3 over 4x. Now, at this point, I can make my fractions a little bit simpler by canceling things out. So I can see that this 2 and part of this 4 cancels and turns into a 2. This 1 we can just get rid of because you know it's just an implied 1. And then 4x cancels 4x. We have now officially gotten rid of every single fraction, and this will be so much easier to solve. So pulling this down, we now have 2x, x minus 5, and then plus that 4x, nothing really happened to it, times the 3, and then that equals the last part, which is x plus 3. Okay, so now I can simplify by multiplying all that stuff out. So I now have 2x squared minus 10x, and then I now have plus 12x equals x plus 3. So now I'm going to combine like terms and set it in ABC order so I can solve this quadratic. So combining like terms, this 10x and this 12x turns into a 2x equals x plus 3. Subtracting x from both sides, I get 2x squared plus x equals 3. And then subtracting 3 from both sides, I get 2x squared plus x minus 3 equals 0. So now, last but not least, we factor our quadratic. You love to see it. So factoring, we have a 2x here and we have an x here. So we need something that multiplies to 3 but adds to 1. Well, 3 only has 1 and 3 as the factors. So now we just have to align them correctly. So we have 1 times 2 plus 3. Well, that's going to be 5. Well, I did something wrong. I need to remember that if it's c is negative, that means one of our signs is going to be different. So this would actually be 1 times 2 minus 3, which is going to be a negative 2. Right, so let's try again. Maybe the sign has to be on the other side. So 3 minus 1 times 2, which is going to be a nice 1. And I just realized I made a mistake right here. That is a negative 1. Alright, So we needed this combination because we need a positive one, so that means the 1 is going to be multiplied by 2, so 2 is over here, and not 2, 1 is over here. Making a lot of mistakes right now. And then I assign my sign, so this is negative, this is positive, equals 0. Alright, so last things last, I have to set these guys equal to 0, so I have 2x plus 3 equals 0. So that's going to be 2x equals negative 3, divided by 2, so negative 3 halves. Then I have x minus 1 equals 0, so add 1 to both sides, and then we have x equals 1. Now, we have to check for excluded values. So remember from yesterday, I need to look at each of my denominators and look for the one that has a variable. So over here, my excluded values, the only one I have is 4x equal to 0, so x cannot be 0. So going back down here, we have to look for 0. Well, we didn't get 0 for either of these, so they're good, and we have our solutions. Alright, so let's move on to the second example. Alright, so we have 2/3 equals 1 over 6x plus 5x minus 10 over x squared. So, first thing I notice is that we have multiple fractions. It's more than just an equal to situation. So it tells me we need to look for the lowest common denominator. So I have all these denominators of 3, 6x, and x squared. So I need to look for that lowest common denominator. So what can I multiply by each of these to get them to one singular number? Well, we're definitely going to need an x squared. And can we get 3 to 6 somehow? Yes, we can multiply by 2. So that means we're going to have 6x squared as our least common denominator. Okay? So I'm going to write that over here. So that means I'm going to multiply everything on top of my denominators by 6x squared. So that means I'm going to have 6x squared times 2 over 3 equals 6x squared times 1 over 6x squared. I'm sorry, just 6x. And then we have 6x squared times 5x minus 10 all over x squared. So now I'm going to cancel out things that are, allowed to be canceled out. So the 3 and the 6, they can reduce, and that will now be a 2. 6x and 6x squared reduce, and so this is now only an x. 6x squared, only the x squareds cancel, so we're left with a 6. So now we have 2 times 2 equals x times 1 plus 6 times 5x minus 10. And I realized I forgot something on my first term, and that is the x squared, because this x squared did not cancel out at all. So I almost forgot that. Alright, so now I'm going to multiply. So now I have a 4x squared, a x, and then I have a 30x minus 60. Alright, now I'm going to combine like terms. So I have 4x squared equals 31x, because x plus 30x is 31, minus 60. I notice I have a quadratic, so that means I have to set that a, b, and c equal to 0. So I'm going to move everything over to the left side. So that means I'm going to have 4x squared minus 31x plus 60 equals 0. And we don't have a GCF, but we can factor this. I want to see if we can graph this first, so I'm going to pull up Desmos and see if it is a nice number. If not, we're going to have to use quadratic formula. So let's pull out Desmos. Alright, so I've graphed this in Desmos, and I see I do have two intersections. I have one here and one here. Those look like some nice numbers. So I'm going to go ahead and try and factor this. Alright? So that means I'm going to have something like this, and we're going to have 4x here and x here, and we're going to need to get to 31. So that tells me we're going to have to multiply 4 by something small, but around the same number to add to 31. So we have 1 and 60, 2 and 30, 3 and 20, 4 and 15, 5 and 12, 6 and 10, 8, 9. And that's it. So 4 times 1, nope. 2 times 4, nope. 3 times 4, 12, 20, close, but not quite. 4 times 4, 16, 16 plus 15, that works. So we can see that 4 times 4 plus 15 is going to equal 31. So I have to put 4 here and a 15 here, and I put both minuses because of my C and B, and equal to 0. So now all I have to do is set both of those equal to 0. We have 4x minus 15 equals 0. And so I get 4x equals 15. And then I get x equals 15 over 4. Alright, and then I have my other side, so x minus 4 equals 0. And then x equals 4. So I got those two solutions. But I'm not done yet because I have to check for those excluded values. Alright, so I'm going to go back up here. So my excluded values is only the denominator. So I see I have a 6x in the denominator and an x squared in the denominator. So divide by 6, I get x equals 0. Square root of 0 is 0, so we have x equals 0. So as long as x does not equal 0, we're good to go. Well, x does not equal 0 for either of our answers, so we're good to go there. Alright, so one thing I do want to mention is that sometimes we won't get these nice quadratics, so you might have to use the quadratic formula. Things from previous units will come back, so make sure you know that quadratic formula and how to use it. Alright, so if you don't have any questions, comments, or concerns, make sure to write down your notes. I realize I messed up that ending. Have a great day and stay safe.